Grade 5 Math, Topic 7, Lesson 5, Add and Subtract Fractions. This video is a review from what you previously learned this year on adding and subtracting fractions in 5th grade. I'm going to do a few worked examples with you to refresh your memory. The biggest note that I have to remind you is you must always have common denominators when you're adding and subtracting fractions. More recently in 5th grade, you were dividing and multiplying fractions where you didn't have to have that common denominator to be able to solve the problem. Addition and subtraction, you have to have a common denominator. You can pause the video and read this problem. I'm looking down here at the equation that they want you to solve. To find the common denominator from 1/3, 1/4, and 3/8 to be added together, you have to have a number as the denominator that all three of those numbers have in common. When I tell my kids in class to solve this, I tell them to run the numbers. That means running the multiples of that number. So we have 3, 4, and 8. So for 3, 4, and 8, I usually tell my kids to do the first 5 or 6 multiples of the number to see what they have in common. So I'll just list out some of the multiples for 3. 3, 6, 9, 12, 15, 18, 21, 24, 27. Now let's do 4. 4, 8, 12, 16, 20, 24, 28, 32. All right, let's do 8. 8, 16, 24, 32, and I could stop there. So let's see what we have in common. So 3, I see 12 with 3 and 12 with 4, but I don't have 12 and 8. So I can't use 12 just because 3 and 4 have it in common. All three of these numbers have to have a number in common. So I have to keep going. 18, nope. 21, nope. 24, oh, so 24 is here with 3, 24 is here with 4, and 24 is here with 8. So 24 is going to be my common denominator. Now I need to work with the fractions to change them that they have the denominator of 24, but I have to do some work with the numerators. So I set the problem up like this. 1/3 times some number is going to give me a denominator of 24. So what times 3 gives me 24? That's going to be 8. So I do 8 on the bottom, 8 on the top. Whatever I do on the bottom, I have to do on the top. So 1 times 8 is now 8. So my new fraction that's equivalent to 1/3 is 8/24. So I have that here, and you also see it in the problem right here. Now let's work with 1/4. So I have 1/4 times some number gives me a denominator of 24. 4 times what is 24? 4 times 6 is 24. Whatever I do on the bottom, I do on the top. 1 times 6 is 6. So my new fraction that's equivalent to 1/4 that has the same denominator as 24 is 6/24. And you see that in the problem right here. Now I need to work with my 3/8. So I have 3/8 times some number is going to give me 24. When I look at 8 times blank equals 24. 8 times 3 is 24. 3 on the bottom, 3 on the top. 3 times 3 is 9. So my new equivalent fraction to 3/8 is 9/24, and you see that in the problem here. Now all of them have the denominator of 24. Now you just do addition across the numerators, because the denominators are now the same. That's what she set up in step 2. So when they add 8 plus 6, they got the numerator of the 14 and then the denominator of 24 still. We don't add the denominators together, they just stay the same. Then I had 9/24 that needed to be added together. So 14 plus 9 gives you 23, and the denominator of 24 stays the same. You do not add the denominators together. Let's look at another example that I have on this page for us. I have 1/12 plus 7/9. Just because it is written vertically does not change how this problem is solved at all. So let's look at here. We have 12 and we have 9. So we have to find a number that both of them have in common. So I can count by 12s. 12, 24, 36, 48. Now I can count by 9s, and since it's only 2 numbers, this is a little bit easier so you know when to stop. So I have 9, 18, 27, 36. Oh, 36. Those two numbers are in common. So I know that I have the common denominator of 36 and 36. Now I need to work with the numerators to create equivalent fractions to be able to add them. So I have 1/12 times some number equals 36 on the bottom. So 12 times what is 36? 12 times 3 is 36. Whatever I do on the bottom, I do on the top. 1 times 3 is 3. So my new fraction that's equivalent to 1/12 that I'll be using is 3/36. Now I have to work with 7/9. Some number times 9 gave me 36. That number is 4. Now I need to do 4 on the top because I did it on the bottom as well. 4 times 7 is 28. So my new equivalent fraction to 7/9 is 28/36. Now I am able to add these two numbers together. Remember, you do not touch the denominators. The denominators are going to always stay the same once you change them to be equivalent. So my denominator is 36. I have to add 3 plus 28 to get my new numerator. So 3 plus 28 is going to be 31. So I have 31/36 as my final answer for 1/12 plus 7/9. Let's look at another worked example. In this example, we also have to remember our order of operations. We have our parentheses, multiplication, division, and then addition and subtraction. So we have to solve what's in the parentheses first. So looking here, we have a denominator of 2 and a denominator of 8. Because what I have in the parentheses, both denominators are the same, I can just automatically add those fractions. So 1/8 plus 1/8 gives me 2/8. Now I have 1/2 minus 2/8. I need to change these fractions so that they have the same denominator. So I have 2 and I have 8. So 2, 4, 6, 8, 8, 16. Oh, look, 8's in common right there, so I can stop. I have 8 already, so I do not have to touch that fraction, but what I do need to work with is 1/2 because it has to have the denominator of 8 as well. So 2 times some number is 8. 2 times 4 is 8. Whatever I do on the bottom, I do on the top. 4 times 1 is 4. So now my new equivalent fraction to 1/2 is 4/8. So if I rewrite my equation, I have 4/8 minus 2/8 equals 4 minus 2 is 2. And 2 over 8 because I don't do anything different with the denominator that I have in common. And my final answer is 2/8. You may be asked to look for a different answer because this is not in its lowest terms. So if you do not see this as a multiple choice answer, we need to see how we could possibly simplify this fraction into another equivalent fraction with lower terms. Whatever I do on the top and bottom need to stay the same. So I have 2/8. I can divide by 2 on the top and 2 on the bottom, and I would get another equivalent fraction. So 2 divided by 2 is 1. 8 divided by 2 is 4. So another equivalent fraction for this answer could be 1/4. So just be on the lookout. If you don't see your answer, it's not that you did it wrong. You may have to put it in lowest terms. Let's look at this last example. Inside the parentheses, I'm going to do that first. Well, I don't have the same denominator, so I need to work with those numbers. So I have the denominator of 2 and the denominator of 20. Well, looking at this, as you're getting better with numbers, you know that 2 can go into 20 10 times. So 20 is going to be my lowest denominator that they would have in common. So I'm going to leave 3/20 alone. I'm going to work with the 1/2. The 1/2 that I have, I'm going to take and multiply it by some number to give me a denominator of 20. 2 times 10 is 20 on the bottom, on the top. 1 times 10 is 10. So my new fraction that's equivalent to 1/2 is 10/20. So I can rewrite this as 10/20 plus 3/20 minus 2/20. So 10/20 plus 3/20 is going to be 13/20. Remember, I don't do anything to that denominator. Minus 2/20. 13 minus 2 is 11/20. So my final answer is going to be 11/20 for this problem.